Good afternoon to all. Welcome back to chemistry class. I hope all of you safe. Today we are going to study about chemical bond and octet rule. Today we are going to study about chemical bond and octet rule. Listen carefully, take notes, use separate note for chemistry. Whatever topics I take, everyone should write in your note. Okay, students? Okay. First upon, we can start with chemical bond. What do you mean by chemical bond? What do you mean by chemical bond? The attractive force that holds two or more atoms together in a molecule is called chemical bond. What do you mean by chemical bond? The attractive force, the force of attraction between two atoms to form molecules. Okay. So, what do you mean by chemical bond? The attractive force that holds two or more atoms together. Attractive force that holds two or more atoms together in a molecule is called chemical bond. We consider two atoms A and B. We consider two atoms, atom A and atom B. When these two atoms comes closer, a force of attraction takes place there. When these two atoms come closer, a force of attraction takes place there. These force of attraction we called as chemical bond. These force of attraction we called as chemical bond. Okay. So these force of attraction we called as chemical bond because this chemical bond or attractive force AB molecule is formed. AB molecule is formed. Okay. The attractive force between the two atoms to form the chemical bond between them, and this chemical bond, because of this chemical bond, AB molecule is formed. Because of this chemical bond, AB molecule is formed. Okay, what do you mean by molecule? Already we learnt about that. Two or more atoms chemically combined to form the molecule. Okay, so here the A and B atoms, it come closer, it form the force of attraction takes place. So this force of attraction we call this chemical bond. Because of this chemical bond, AB molecule is formed. Okay, understood, students? Then why do atom combine? Why do atom combine? Because of chemical bonding, you know. Why do atom combine? Because of chemical bonding. How chemical bonding is formed? How chemical bonding is formed? Let us discuss now. Listen carefully. First upon, how chemical bonding is formed, we will explain. I will explain that with octet rule. I will explain that with octet rule. Okay, what do you mean by octet rule? Listen carefully. The atoms does not exist in free state except noble gas. The atom does not exist in free state except noble gas. Okay, because the noble gases only have the stable electronic configuration. So it does not react with each other and it does not combine with any other atoms or molecule. Okay. How the noble gases exist in stable? It can explain by octet rule. It can explain by octet rule. Okay. What do you mean by octet rule? What do you mean by octet rule? Octet rule means the tendency of the atoms to have 8 electrons in their outermost orbit. Okay, the tendency of atoms to have 8 electrons in their outermost orbit. All of you know about the orbit. Orbit means, what do you mean by orbit? The circular path. The electrons are revolving around the nucleus. That is called orbit. Okay, so the outermost orbit, otherwise we call this valence shell or valence orbit. Okay, the outermost electrons, which is otherwise called as valence electron. The outermost electrons, the electron present in the outermost orbit, otherwise we call as valence electron. Students, remember this, very very important. What do you mean by valence electron or valence shell? The electron present in valence shell is called valence electron. Okay, you know about that. Orbit means there are 4 types of orbit, K, L, M, N. Already we studied about that. Okay, the 2 atoms, totally 2 atoms can occupy in K shell, and totally 8 electron can occupy in second orbit, and 18 electron we can occupy third orbit, and 32 electron we can occupy fourth orbit. Already we studied about that. Okay, now it has come to the octet rule. Octet rule means the tendency of atoms to have 8 electrons in their outermost orbit. Tendency of atoms to have 8 electrons in their outermost orbit. This is called octet rule or rule of octet. Okay, here the noble gases only have 8 electron in their outermost orbit. All the other atom does not have the 8 electron in their outermost orbit. So the noble gas is only stable. Noble gas is only stable. Okay, understood? But in the case of helium also noble gas, but helium atom only 2 electrons. 2 electrons, atomic number 2. You know about what do you mean by atomic number? Atomic number means number of electrons. Okay. So helium only having 2 electrons in their outermost orbit. Okay. So this helium atom only 2 electrons, but it is also stable. So it is, we call this doublet rule or rule of 2. Doublet rule or rule of 2. Okay, understood? And then how the noble gases obey the octet or doublet rule. How the noble gases obey octet or doublet rule. Let us study. Listen carefully. Okay, wow. What are noble gases? What are noble gases? We know our modern periodic table. About that, you know, there are 7 periods and 18 groups in the modern periodic table. The group 18 elements we call as noble gases. Okay, group 18 elements we call as noble gases. What are they? Helium. Already we studied about that. Helium, neon, argon, krypton, xenon, and then radon. Helium, neon, argon, krypton, xenon, and then radon. Okay. And what about this atomic number? Helium 2, atomic number 2, neon atomic number 10, argon atomic number 18, krypton atomic number 36, xenon atomic number 54, radon atomic number 86. Okay, atomic number means number of protons or number of electrons. Okay, so the helium atom have 2 electrons, atomic number 2. So here having the 2 electrons. Okay, how it fill the orbit? The 2 electron Only 2 electrons have. So the electronic configuration 2. Okay, and neon, the total atomic number 10, number of electrons 10, we can write. First shell we can occupy, first orbit we can occupy 2 electrons, second orbit we can occupy 8 electrons. Okay, the argon, first orbit we can occupy 2 electrons, second orbit we can 18, atomic number 18. So first orbit we can occupy 2 electron, second orbit we can occupy 8 electron only, and third orbit we can occupy 8. So 2 plus 2 8, 2 plus 8 10, 10 plus 8 18. Okay, here krypton. What are the atomic number of krypton? 36. Okay, wow. So how much electron we need? Remaining 36 minus 18. Okay, we need 18 elements. Okay, 18 electrons. Okay, first orbit we can occupy 2 electrons. Second orbit we can occupy 8 electrons. And third orbit we know, third orbit we can occupy maximum number of electrons 18. And finally last 8 electrons. Okay, and then xenon. Xenon atomic number 54, number of electrons 54. Okay, so how much remaining from the krypton? 54 minus 36, we get 8 1. Here also 18 electron we need. Okay, so first orbit we know 2 electrons, second orbit 8 electron we can occupy, third orbit we can occupy 18 electron, and other 18 electron, another orbit 18 electron we can occupy, finally 8 electron in the last orbit. Okay, understood? And then radon, atomic number 86, atomic number 86. So remaining from the xenon, 86 minus 54, we can get 32. Okay, you know, first orbit 2 electron we can occupy, second orbit 8, third orbit 18, you know, fourth orbit we can occupy 32, and then 18, and finally 8. Okay, so all these electron elements, all these inert gases, these are the inert gases, all these inert gases have 8 completely filled electrons, completely filled 8 electrons in the outermost orbit. Okay, so these noble gases obey the octet rule. Noble gases obey the octet rule, so it is stable. It does not involve any combination of atoms. It is in free state. Okay, but all the other atoms does not exist in free state. Okay, because all the other atom does not having the 8 electron in the valence orbit. Okay, now we can write this electronic configuration according to alpha principle. Yesterday we learned about that. Alpha principle means the electrons are occupy in the subshell. Occupation electrons in subshell or orbital. Okay, how to write? First 1s orbital, 2s orbital, 2p orbital, 3s orbital, 3p orbital, 3d orbital, 4s, 4p, 4d, and 4f, 5s, 5p, 5d, 5f, 6s, 6p, 6d, and 7s. First, and then okay, clear now? Okay, the helium atomic number 2, neon atomic number 10, argon 18, krypton 36, xenon 54, radon 86. Okay, how will you write the electronic configuration? First, helium, 1s2, and neon, 10 electrons are present here. So 1s2, 2s2, or otherwise we can write helium 2s2. For the 2 electrons we can take the helium because helium is the nearest noble gas. Okay, but here these noble gases, group 18 elements, the general electronic configuration NH2 and NB6. NH2 and NB6. So it should have 8 electrons in their valence orbit. Okay, wow. So helium 2 electrons, helium only 2 electrons. Then neon atomic number 10. So we can take helium, nearest noble gas helium, we can take helium and remaining electrons, 8 electrons are remaining. So 2s2 and then 2p6, s orbit maximum number of electron 2, p orbital maximum number of electron 6, d orbital 10, f orbital 14. Okay, understood? And then argon. Argon atomic number 18. How will you write the electronic configuration? How will you write? First upon 1s2, 2s2, 2p6, 3s2, 3p6. Okay, 18 electrons. For 10 electron we can take neon. Okay, wow. The neon is the nearest noble gas. So neon 3s2, 3p6. Okay, understood? And then krypton, about the atomic number 36, number of electrons 36. Okay, so 36 remaining from the argon, 36 minus 18, 18 electrons, remaining 18 electrons we need. So nearest noble gas for krypton, argon. Argon we taken as the nearest noble gas, and argon totally 18 electrons are there. We need 18 electrons. Okay, so here 3s2, 3p6 up to here we taken. After that 3p6, after that 4s2, 4s2, 18 electron we need. The 2 electrons is orbital, 4s2, and then 3d10, 3d10, and then 4p6. Okay, 3d10 and then 4p6. But our general electronic configuration for group 18, NH2, NP6. N means number of orbit. Okay, wow. Here 4s2, 3d10 and 4p6 are there. So we can write argon 3d10. It is present in inner shell, inner subshell, and then 4s2, 4p6. Okay, understood? And then xenon. Xenon atomic number 54. So number of electrons 54. So nearest noble gas krypton, and remaining electron 54 minus 36, remaining 18 electrons are remaining. So 18 electrons are we need. So if we completed with 4p6, after that 5s2, 5s2, 4d10, then 5p6. Okay, the general electronic configuration NH2, NP6. So 4d10 goes to the inner shell. So we get krypton 4d10, 5s2, 5p6. Okay, and then radon 86 atomic number. How to write? The krypton is the nearest noble gas. We completed with 5p6. After that we can write 6s2 and then 4f10, 4f14. Here we need how much electron we need from krypton? Radon 86, krypton, xenon 54, 32 electron we need, 32 electrons we need. Okay, here we are taking xenon as nearest noble gas. Xenon we taken as the nearest noble gas for the radon, and we need 32 electron again. We completed with 5p6. Then we can write 6s2 and then 4f. How much electron? F orbital 14, 4f 14, then 5d 10, and then 6p 6. Okay, count how much electrons are there. 14 plus 2, 16. 16 plus 10, 26. 32. Okay, 32 electrons we get. Okay, outer electronic configuration NH2 NP6. So we can write xenon. The 4f14 and 5d10 goes to the inner shell. 4f14, 5d10, final 6s2, 6p6. Okay, students, understood? So all the noble gases have 8 electrons in their valence orbit. Valence shell. Valence shell have 8 electrons. Okay, so it becomes stable. Okay, understood? So they assumed that since the atoms of noble gases do not normally react with other atoms to form compounds, because the atoms of noble gases is a stable configuration of 8 electrons, which they are called octet. Okay, understood? But helium only having 2 electrons. This helium also stable, so we are called as doublet complete or duet complete. Okay, understood? What about other atom? What about other atoms? Listen carefully. Except noble gases, all the other atoms does not exist in stable. Except noble gases, all the other atoms does not exist in stable. Okay, except noble gas, all the other atoms does not exist in stable because they are not having 8 electrons in their outermost orbit. Okay, because they are not having 8 electrons in their outermost orbit. So they are try to get stable by losing or gaining or sharing electrons. Okay, when atoms are losing or gaining or sharing electrons, when they are losing or gaining or sharing electrons, The force of attraction takes place when atoms are losing or gaining or sharing electrons. The force of attraction takes place between them. This force of attraction we called as chemical bonding. Okay. Thus, the chemical bonding is formed. If the atoms become stable, it should have 8 electrons in their valence shell or valence orbit. Okay. If the valence shell has 3 electrons, it is not stable. If it is 5 or 7 electrons, it is not stable. It should have 8 electrons. It should have 8 electrons. Then only that atoms are stable. Okay, students. Here you understood about that electrons only involving in the chemical bonding. Okay. Let us explain with example how the chemical bondings work. Let us explain with the example. Okay. First upon we know helium. This is the atom. This is the nucleus. Nucleus having protons and neutrons. Electrons are revolving around the nucleus. Helium atom having 2 electrons. So the electronic configuration of helium 1s2, only one orbit is there. 2 electrons are present here. Okay, so no need to lose or gain electrons for helium atom. So it becomes stable. Okay, understood? But in the case of hydrogen atom, this is the nucleus and this is the first orbit. Hydrogen atom, how much electron? Only 1 electrons there. Atomic number 1. So only 1 electrons there. So hydrogen, it is not stable now because only 1 valence electron having. Okay. So it try to gain one more electron from any other atom to get stable. So hydrogen atom does not stable now. So it always try to get 1 electron with any other atom. When it get 1 electron from any other atom, it is bonded with, the force of attraction takes place with that. So the chemical bond is formed between them. Okay, understood? So another one example, neon. Neon, atomic number 10, electronic configuration 2, 8. Okay, so neon nucleus, first orbit 2 electrons, second orbit 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8 electrons. So it has 8 electron in the outermost orbit. So no need to lose or gain or share electrons with any other atom. So it is always stable. Okay. But in the case of sodium, sodium atomic number 11. So electronic configuration 2, 8, 1. So sodium, this is the nucleus. This is the first orbit, 2 electrons. Second orbit, 8 electrons. And last orbit, only 1 electron is there. Okay. So sodium atom not stable now because only 1 electrons in the outermost orbit. Okay. So it always try to lose this electron. Okay. Try to lose this electron with any other atom. Then only it can stable. Okay. So when the sodium atom lost this outermost electron with another atom, the force of attraction between formed between them, this force of attraction we can call as chemical bond. Okay, understood? Okay, so these are about the chemical bond. What are the types of chemical bond? What are the types of chemical bond? There are four types of chemical bond. Four types of chemical bond. They are ionic bond. They are ionic bond, covalent bond, coordinate covalent bond, and metallic bond. Okay, there are four types of bond. What are they? Ionic bond, covalent bond, coordinate covalent bond, and then metallic bond. Okay, understood? About these four types of bonds. Next class we can study. Okay. So today assignment. Today assignment. What is chemical bond? What is chemical bond? Second one. What do you mean by octet rule or rule of octet? Okay, these two questions you should write and send me through WhatsApp. Okay, understood? Thank you all of you.